Hey guys, so today we are going to be talking a little bit about velocity and types of motion. So we have seen that speed and velocity mean similar things but they are not the same. So velocity, like we remember, is speed but along with direction. Now this direction aspect is important because objects don't always move in the same direction. We always keep changing the way we are moving, right? It's not always a straight line. Sometimes it's like a curved path, for example, right? Simple example is if you see there's this piece of thread with a syringe attached to it, right? That's the syringe we used in the activity. If I move it around, my syringe is spinning with some speed, but right now I don't know which direction it's going in. It's just going in a circular path. Okay, so to understand the direction of this, there's one thing that I can do. I can leave this syringe at any point of time. For example, I'm just going to leave it when the syringe comes over here. Okay, so you'll notice that whatever point of a curve this object is on, it will move exactly at a tangent to it, right? So velocity is necessary because to understand the movement of objects on a path that is curved. Alright, now there are two types of motion that we majorly talk about. Okay, now we can categorize them based on how they behave. Alright, to give you a bit of a clear example, we're going to take two examples on the board. Right, I want you to try to follow it and understand what it is. It's very simple. Okay, I will be talking about two people right now. Okay, person A and another person B. Okay, so there are two people who are going on the same path. Alright, I will take the same path for them, which is 10 meters long. Okay, or let's make it 20 meters long this time. Both of them are moving on the same path of 20 meters long. Okay, both of them are moving for 5 seconds only. Okay, I am saying total time has to be 5 seconds only. Now one person, what he is going to do is, in the first second he will go by 4 meters. Okay, in the second second he is again going to cover 4 meters, again 4 meters, again 4 meters, and to make it a total of 20 I'll have to extend it. So now if you see, this person has taken 5 seconds. In each second I have shown you where it starts. A to B 4 meters 1 second, B to C same. Okay, now the second person, what he is going to do is, first he covers, let's say, some 5 meters in 1 second. Okay, then next he'll cover some 3 meters in 1 second. Okay, then I'll say he covers some 4 meters in 1 second. Then I'll say that he covers some 6 meters 6 meters in 1 second, and lastly he covers 2 meters in 1 second. Okay, so both of them have taken exactly 5 seconds each, but notice that this person has covered different distances and this person has covered different distances for the same amount of time, but the total 5 plus 3 8 12 8 18 20. Okay, so for this person my distance would be something like this. Remember the table that we drew? So I will draw the same type of a table, okay, for A and B. This is A, this is B, okay, distance, time, okay. At 0, both of them are at 0. At 1 second, this person has finished 4 meters. After another second, he has finished 4 plus 4, 8. At 3, 4 plus 4 plus 4, 12. Same way at 4, he has finished 16 meters, and finally when his 5 seconds are done, he is done with 20 meters total. If I look at this person, in 1 second he has covered 5, in the next second he has covered 3, so 5 plus 3 is 8. In the third second, 5 plus 3 is 8, 8 plus 4 is 12, right? In the fourth second, he has covered 18 meters plus 6, right? And finally, by the end, he has covered 20 meters total. So you see the total for the ending result is the same for both, but there will be a difference when it comes to not just simply looking at the numbers but also looking at their movements, right? Now what I will show you is, I'm going to make the same graph that I made in the last class, what we call as a distance time graph, okay? Okay, time, distance, time and distance. This is for person A, this is for person B. Okay, now both of them start at 0. 1 2 3 4 5. 1 2 3 4 5. Okay, now since it is 20, I can't put 20 here, so I will put 4 4 each. Okay, 1 centimeter is 4 units. 4 8 12 16 and 20. Same way 4 8 12 16 20. Now I will notice that for the first person I can mark 1:4 over here, 1:4, then 2:8, 2:8, 3:12, that will be this point, 4:16, that would be this point, and 5:20, and that would be this point. Now if you see all these points, if I try to connect them, I can connect them in exactly one perfectly straight line, right? Now if I look at the other person, at 1 second he is at 5, okay, which will come somewhere above 4. Then at second he is at 8, so that would be, this would be somewhere around 5, this would be 8, okay. Then at 3 he is 12, This will be much neater if done on a graph paper. I'd actually advise you to do it on a graph paper. Now 4 is at 18, which is very close to 20, right? 4 is to 18 and 5 is to 20. So nothing but somewhere over here. Now you'll notice I cannot connect this graph with one straight line. Okay, first it will go like this, then it will go kind of like this, then like this, then it will go like this, it will go like this. Right, so you see it, right? One is a perfect straight line, one is not. This is what we call as uniform motion. Okay, and this is what we call as non-uniform motion. So to put it simply, whenever an object covers equal distances in equal amounts of time, so you see the time frame is the same and the distance covered in it is the same, then this object is said to be in uniform motion. If it does not cover equal distances in equal intervals of time, it is not uniform motion. Okay, like 1 second, but one is 5 and one is 3, right? So even if one variation is there, right, even if only one of them, even if say this became 3, then this will also be non-uniform. Okay, so this is majorly the difference between uniform and non-uniform motion. These are the definitions, and that would be the end of today's class.